So Priscilla is the one that's helping us with the CDKL5. She was actually the one who received Harper cells, expanded, and will show us the different steps of this reprogramming procedure.
Okay.
Yeah.
Thank you.
What happens in this room is we have lots of cells that are in those incubators here, and we keep them in conditions that mimics the human body. So they are at the right temperature, the right humidity, the right levels of oxygen. So they grow really nice in there. It's a very sterile environment, and you can manipulate your cells in there.
So she's in that dish.
Yep, and
That
these
is
are cells from her
sad.
skin.
That
Yep.
is so cool.
These are the actual cells.
So are they
Yeah.
living?
Yes, they are. They are proliferating.
Really?
Yes. And we are currently reprogramming them into iPS cells. We will transform these cells, these skin cells, in stem cells. So then we will be able to generate neurons.
Very cool.
It's what happens when you cut yourself and you have like kind of scar tissue that
Yes,
proliferates.
yes.
That's what's happening.
That's what's
in the dish.
happening?
Yeah.
Oh, that's so
Wow.
cool.
The
Wow.
cells are attached to the bottom.
To the bottom.
Yeah.
Oh, okay.
Cool.
That's
So
very
she's
cool.
gonna show you now what's gonna happen next.
Okay.
Okay.
These are the stages that we collected and already like are one step ahead.
Fantastic.
So they will
Oh,
become
wow.
this.
Oh,
So
wow.
remember the skin cells are very thin and elongated.
Like hairy.
Now, I mean, each dot of that is a single cell. These are embryonic cells. Each one has like the nucleic acid, the DNA material inside. It's a small dot, and then you can see the rest of the cell.
Wow.
These cells, they have the potency to become any tissue in the body that we use to induce from these cells to the brain cells. And it's a series of steps with different chemicals that we add, that we kind of fool the cells thinking that they are instructed to become a brain. So
Really?
that's what we do. So these are cells that were derived from that embryonic stage, but now these cells will give rise to all cell types in the brain. It seems like it's static, but if you do a time lapse, you see
Yeah.
that this process,
Moving around.
they are
Really?
moving around. Yeah.
Wow.
And what they will do if you let them do it, they will try to find partners and
Connect.
kind of connect
Yeah.
and start to elongate the process and sending like all these neuronal process to each other. That's what's going to happen.
But this is so huge, bigger than I had thought it would be. To be able to donate to science in such a way, what a remarkable gift she gave to so many people, to beyond her disorder, and I'm just very proud of her.
And takes about, this is 4 weeks old or
These are 3 weeks, not
3
4
weeks.
years.
Oh
Yeah.
wow! So it doesn't really take like tons of
No,
time for
no,
this. Wow! Oh wow! Look at this, Dustin.
This is 3 weeks.
this is 3 weeks after that
Wow.
After what
previous
you just
stage.
told me.
Yeah.
Wow.
We kind of change the media and induce with those factors, and that's what they will do. They will
Oh,
send the signal
yeah.
everywhere.
That is-
Actually, right now we are just recording from them.
Okay.
It's like we are listening what they're talking to.
Gotcha.
Okay.
And
Okay.
as the time passes, as we keep like for more weeks, these networks will mature more and more. And you can see that the communication in the beginning is really noisy. There's lots of signals here and there. As they mature, they start to synchronize. It's almost like the whole dish start talking to each other
Really?
in a very synchronized way. So that's
That's
one
so
of the
cool.
first differences that we see from neurological disorders,
Yeah.
autism, Rett syndrome, CDKL5. The synchronization is messed up.
It's off a little
they,
bit.
They
yeah.
are not making the proper connections to have this kind of talk.
Wow.
Yeah.
It's phenomenal to understand. I had no background in this, didn't really know what to expect, and I just am floored at really how impactful this is, and proud that she's able to do it.
I just hope that her final donation to the world will bring something very positive, which what we saw today, we're 100% sure it's going to lead to something huge. We don't know what, and we do know what the research is, what they're doing with the research and what directions they're going. We just hope that it will impact, that her donation will impact the world in some unbelievable manner. That would, even though it's hard that she's not here, it would make it more palatable. And that's what we hope for.
I am so fortunate that we were able to connect with the right people, the right organizations to be able to donate her. What we saw and what we held today, those are living cells. Harper lives, and her legacy of hope lives on. And it was a collaborative effort among many, many organizations and many people to get her here. So I have to thank all of those people that helped make this possible, because I got to hold my baby girl on her birthday. So it was very emotional to see her today.